In Chapter 8, we're going to cover roots and radicals, and I'd like to start off by making a chart of our perfect squares, initially to refer to, but eventually you need to commit these to memory. So in the first column, we have the value being squared, and in the second column, we have our perfect squares. So 0 squared, of course, is 0. So 0 is a perfect square. 1 squared is 1. 2 squared is 4. 3 squared is 9. 4 squared, we get 16. 5 squared is 25. 6 squared is 36. 7 squared, we get 49. 8 squared is 64. 9 squared is 81. And 10 squared is equal to 100. These are the main ones you need to know. 11 squared is 121. 12 squared is 144. Some of you may already know those. Now let's take a look at our variables. X squared, of course, is x squared. But what happens when we square x squared? Well, we multiply those exponents and we get x to the 4th power. What happens when we square x cubed? Well, we multiply the exponents and we get x to the 6th power. X to the 4th squared, well, again, multiply the exponents and we get x to the 8th power. X to the 10th power and x to the 12th power. Here we have x to the 14th power. It's getting a little redundant, isn't it? X to the 16th power, x to the 18th power, x to the 20th power, and x to the, well, this time we're squaring x to the 50th power, so we get x to the 100th power. What do we notice about all our exponents in the perfect square column? Well, we have 2, 4, 6, 8, 10, 12, 18, 20, 100. Every one of those is even. In fact, we can make a general statement here. In fact, we can say that a variable raised to an even exponent is a perfect square. So whenever we see a variable raised to an even exponent, we know that that's a perfect square. Now, it's very, very important that you learn to recognize these perfect squares. Okay, definition. For any real numbers, a and b, b is the square root of a if b squared is equal to a. Let me give you a numerical example. We know that 7 squared equals 49. Well, first of all, since something squared equals 49, that's in this case a perfect square. 7 is the square root of 49 since 7 squared equals 49. So we could say the square root of 49 is 7. Now, think about opposite operations. They undo each other. You've been dealing with these for a while. When we're dealing with algebra, we know that addition and subtraction are opposite operations. They undo each other. Multiplication and division are also opposite operations. They undo each other. Well, squaring also has an opposite. The opposite of squaring is to take the square root. Since 5 squared equals 25, the square root of 25 is 5. But negative 5 squared is also 25. So the square root of 25 is also negative 5. There are 2 square roots associated with the square root of any positive number. There's the positive square root. And there's also the negative square root. To find the square root of 25, we ask ourselves, what number squared equals 25? And above, we had said, well, 5 squared equals 25. And we also said negative 5 squared equals 25. Find the square roots of 36. Ask yourself, what number squared equals 36? And remember that there will be two numbers that when squared will equal 36. There will be a positive and a negative. If you need to, go to that chart we made in the first place. We'll find that 6 squared equals 36 and negative 6 squared equals 36. Now we use this symbol that we see here, the square root symbol, to denote the positive square root of a number. So the square root of 36 is 6 or negative 6, but when I use this symbol, the square root of 36 is simply 6. If we wanted to express the negative square root of a number, we would have to do that explicitly. We would have to write the negative square root of 36. So we have the negative, and then the square root of 36 is 6. So the negative square root of 36 is negative 6. Every real number squared is positive except 1. That will be 0. 0 squared is just 0. So we can never square a number and wind up with a negative value. So, looking at the square root of negative 36, we'd be asking ourselves, what number squared equals whatever's inside here, which in this case is negative 36? Well, 6 squared is 36. Negative 6 squared is 36. In fact, there's no real number that we can square and wind up with negative 36. So the square root of negative 36 is not a real number. In fact, it's an imaginary number. We're going to come back to that later. For now, you need to know that it's not a real number. Okay, so let's look at some more properties of square roots. Every positive real number has how many square roots? Well, 2. 1 positive and 1 negative. The square root of 0 is, well, 0 squared is 0, so the square root of 0 is 0. We use the symbol, the one shown, for the radical symbol to denote the positive square root of a number. Now, the non-negative square root is called the principal. I don't know why it makes things disappear on me. The principal square root. So the positive square root is the principal square root, but when we take the square root of 0, we get 0. And that's why they say non-negative, to account for the 0 as well. The number under the radical is called the radicand. You need to know that because when I use that term, you need to know what I'm talking about. So looking here, we have the square root of 4. The radicand is whatever is under the radical, so in this case, it is 4. And in fact, I don't like the use of the word number. Let's put the expression. So looking here, we have the square root of a. And first we'll talk about this side. This symbol here is the radical symbol, which is surrounding it. The radicand is whatever is underneath that symbol, which in this case is simply a. We call this the square root, and in this area here is where we put the index. However, when it's a square root, we don't put anything. A 2 is implied, hence square root. If it were a cube root, however, we would need to put a 3 in there. And we're going to come to that later, but I wanted to start to prepare you for it now. So let's see if we can name the radicand in each instance shown here. So whatever is under the radical symbol. So here, the radicand is 3a. And in this case, the radicand is whatever is under the radical symbol, which is 5x squared y cubed. And in this last example, everything under the radical symbol. So we get x squared minus 4.